Brooks coil. Brooks coil has specially arranged dimensions to get the maximum inductance value for a given length of the wire. You see the analytical equation here. I'm going to simulate the Brooks coil in QuickField and calculate the inductance in QuickField. The coil has 200 turns, but there is no need to draw each individual turn. I'm going to model the coil with its cross-section and specify the total number of ampere turns. Okay, let's start QuickField now. In QuickField, I create a new problem. Coil. Next, problem type is magnetostatics. Every simulated device is a three-dimensional object, but the coil features a rotational symmetry, so the model class is axisymmetric. Length units are millimeters. Finish. On the left you can see the problem pane, and on the right is the geometry model editor window. In axisymmetric problems, the axis of rotation is a horizontal one, and I should create only the upper half of the cross-section in the model. First, I will insert a rectangle with dimensions 20 by 20 millimeters, and this rectangle I will place 20 millimeters above the axis. Insert. Close. This is the cross-section of the coil. In fact, the magnetic field is distributed not only in the coil, but also in the air outside. So I need to add the air block. I need to draw the boundary of the air block. Switch to insert mode, click and drag to draw the line and another line. Then change the line type to half arc and draw the arc. Zoom to fit. Now let's assign labels. Through labels you can explain the geometric object's meaning and provide material properties. Switch to select objects mode, click to select and type in the label name here. This is air, this is coil, and I should assign labels to the external boundaries. QuickField automatically assigns proper boundary condition on the axis of rotation, so I have only to assign label to the arc. External. Now let's provide physical properties for these labels. Double-click the label name in the tree. The permeability of the air is 1. Okay. The permeability of the coil is 1, and the total current is 200 amperes. Total ampere turns. Okay. Far away from the coil, the magnetic field fades to 0, so at the external boundary I specify 0 magnetic potential. Okay. Before I can solve the problem, I should build the finite element mesh. Just press this button and the mesh will be generated. Now save all problem files and solve the problem. Let's take a look at the results. You see the field lines here looks broken. That's because of the insufficient mesh density. Let's solve and refine to get more accurate results. You see QuickField automatically adjusted mesh density. Now let's take a look at the results. Now the field lines are smooth curves, and the field picture looks physically correct. You can adjust the field picture and switch on, for example, the color map of the flux density. And you can switch on the legend to see the correspondence between the colors and the numbers. My task is to find an inductance. I'm going to use the inductance wizard to calculate the inductance of the coil. You can use either the flux linkage approach or the stored energy approach. Next, coil, and there are 200 turns in the coil. Next, coil, and again I should type in number of turns, 200 turns. Next, finish, and this is the inductance value. Let's repeat the calculations again. Now I will use the stored field energy approach. Next, calculate the energy, current, and there are 200 turns. Next, finish. You see the difference is less than 1%. Let's calculate the inductance using the equation provided by the Brooks. So the inductance is 1.6994 times 10 to the power of minus 6 multiplied by 3 divided by 2 multiplied by the coil thickness, which is 0.02 meters, 20 millimeters, and multiplied by the number of turns squared. 2 millihenries. Almost a perfect match. If you search for the Brooks coil on our website, you will find the example page. Here you can read about problem setup, browse the solution section, take a look at the result pictures, and download the simulation files. Simulation files may be opened and the results may be viewed using any QuickField edition, including QuickField Student Edition, that you can download from our website for free.